Hell yeah, this video is just going to be a minute long, but this is a surveying question, and I'm going to go about it with understanding from material mechanics that you have strains on the steel tape that's being used, expansion due to temperature, a tension, so you're going to be stretching it. Also, it has weight because it's made of steel, and when it's being hung, it has a sag to it, and that's all going to change the length. From material mechanics, though, you start with the original length. So you can treat this steel tape like a spring, and even though you're stretching it and then getting its measurement with a specific temperature and a specific tension, it has an original length, maybe still at this temperature, but with no tension, and that would be a spring at its original length. All right, this video is going to be 2 minutes, maybe 3. But that is the original length. And then what you do to it, you strain it, you stretch it due to temperature or pull, then the length changed. But with surveying, you take something that's inaccurate because you're pulling with like 80 newtons at a different temperature that day that's not from the standard, and tension or temperature. And then you're going to use that as a gauge, and you're just going to get wrong answers, but then you have to have a correction. And so here is the equation for the correction. You actually take that measured length and then apply the corrections. And I really haven't looked at this, but you still take that measured length multiplied by the coefficient of temperature and then the temperature change. This alpha, the coefficient, multiplied by the change in temperature, this gives you the strain, but that strain is always based on the original length. So I'm glad I'm just talking my way through here, because I think that is the simplification. To make this a true process, you would need the original length of the spring. You know what I mean? The original length of the steel survey tape with no tension and at a standard temperature. But none of these calculations take that into account, and it drives me crazy because therefore this is wrong. I mean, cool, like the lengths are going to be so minimal in a surveyor's tape, and so you're using a wrong length here, but this is kind of the juice. You know what I mean? You do have up to, I don't know, but these corrections are pretty minimal as well. But if you have a survey tape and you're doing 30 meters after 30 meters, the errors do accumulate. But I think at the end of the day, that is where the hiccup is. You're using the measured length and not using the equations to go back to what the original length of an unstretched spring would be, because that's all a surveying tape is. It's at a certain base temperature. It's an unstretched spring. But then once you do stretch it, bring it into a heated environment, sag it, all those things, or a cold environment, or lay it flat. Lay it flat would be the neutral. You don't have to have any correction there. But hell yeah. So all those things are going to add up, and they're just using the measured length. So I think that's kind of fascinating. Anyway, that's it. And then so I just had to Google this. In surveying, is this equation, for the actual distance of the measured length plus the correction, is this 100% accurate? And it says no, it's not. It's adopted, it's simplified. Now, some of these Google AI things, they're not 100% accurate. But it seems like this one, just because the numbers don't really work out. And then so that's it. It's probably a 4-minute video, but I apologize about that. But just in general, if an equation is going to be simplified, I really do think you need to, you need to advertise what you're doing with it. It's like you made a tool, cool, now tell us how it works. Tell us why it's simplified, what's the limitations. But yes, for simplified equations, if that's what this is, I could be totally wrong on this one, but I just got to a point where I'm just like, oh, this isn't using the original length no more, and how can you use the wrong measured length? And I don't know. But anyway, so hell yeah. So that's just, this comes up a lot. There's plenty of assumptive equations that don't take, like most all physics equations, don't take into consideration everything. But when things get overly simplified, that's when big red flags go off for me, because you can't arrive at some of these equations from a fundamental perspective. Even if it's like, yeah, you can't see where the simplifications were. So anyway, so hell yeah. So I would like to dive more into this and figure out where the simplifications to get this measured length and then plus the correction. And then even like we showed on the correction for temperature, they were using the measured length, where from a material mechanics perspective, you'd use the original length. You would use a base length of, yeah. So, and a known, I don't know. So maybe it comes out in the wash and it's not even that big of a deal. Like maybe that's where it really, I don't know. I can't see it. But anyway, I'm going to end it here. Thanks for joining me. Booyah.